Exercise number 3 of quadratic equations. Okay. Question number 1, sub question 1. This is the nature of the roots problem. X square plus 9 equal to 0. So A, B, and C. A, B, and C. A is 1, B is 0. See, because B is the coefficient of X and there is no X in the problem. C is 9. Okay. So delta B square minus 4AC. 0 square minus 4 into 1 into 9, which is minus 36 lesser than 0. So the roots are complex. They are complex. So if the roots are complex, then complex roots always occur in conjugates. So the roots are complex conjugates. Okay. That conclusion you may write. Second sub question, 4x square minus 24x plus 35 equal to 0. Okay. Now see, A is 4, B is minus 24, C is 35. Delta B square minus 4AC minus 24 the whole square, 4 A into C. Okay. So let us just calculate this. Answer is 16. So it's greater than 0. So real and unequal, because it is only greater than 0, not equal to 0. Okay. So they are real and unequal. Now delta is a perfect square. Delta is a perfect square, and moreover, there are no roots in the quadratic equation. So if the delta is a perfect square and there are no roots in the quadratic equation, so the roots are rational as well. Third one, x square minus 2 root 2x plus 1 equal to 0. A equal to 1, B is equal to minus 2 root 2, C is equal to 1. Delta B square minus 4AC minus 2 root 2 the whole square minus 4A into C. Okay. 8 minus 4, which is equal to 4. So delta is equal to 4, greater than 0. So real and unequal. Okay. Now see, it's a perfect square, yes, but then there is a root over here. So we'll just find out the value of x. Okay. So x is equal to minus b plus or minus root of delta upon 2a minus b. So b is equal to minus 2 root 2. So minus b will be 2 root 2 plus or minus root of 4 upon 2a. A is 1 in this problem. So 2 root 2 plus or minus 2 upon 2. Take 2 common, root 2 plus or minus 1 upon 2. 2 cancel. So this is root is there in the value of x. So it is not rational. Okay. We got a perfect square value of delta, but then that doesn't imply it is always rational. It is because there is a root value in the question, in the quadratic equation. Okay. So one sub question 4 you can try it on your own. Okay. Let's solve question number 2, sub question 4 from the worksheet. Okay. So x square plus px minus q square is equal to 0. Okay. A is equal to 1, B is equal to P, C is equal to minus q square. Delta B square minus 4AC. Okay. So B square, P square minus 4AC. So P square plus 4Q square. Now P square is, positive, Q square is positive. So delta will be greater than 0. Okay. This is one case. So in this case, the roots are real and unequal. Fine, because P square and Q square can never be negative. But then if P and Q are 0 at the same time, P and Q are 0 at the same time, then the delta value will be 0. In that case, delta will be equal to 0. So roots are real and equal. So there are two cases possible over here after this. So the answer is this is greater than or equal to 0. So greater than 0 when P and Q are any number. Okay. Uh, right. So it will be greater than 0. Roots are real and unequal. When I say any number, then at a time both are not 0. Okay. If P is 0, Q is not 0, and Q is 0, P is not 0, or P and Q are two different numbers at all apart from 0. Okay. But then if P and Q are 0 at a single point of time, so delta will be equal to 0 and the roots are real and equal. Okay. So that should be your conclusion. Question number 3, I think I will solve question number 3, sub question 2. 3 sub question 1, you can do it for your self study. X square minus P plus 1 into X plus P equal to 0. A is equal to 1, B is equal to minus of P plus 1, C is equal to P. Delta B square minus 4AC. So B square minus 4AC. Negative will go because of the square. P square plus 2P plus 1 minus 4P. So P square minus 2P plus 1, which is P minus 1 the whole square. Okay. So this value is greater than 0. Okay. If P is not equal to 1. So there are two cases possible. If P is not equal to 1, then this value is always greater than 0 because square will make it positive. So in this case, when P is not equal to 1, then the roots are real and unequal. Okay. Right. And if P is a rational number, then, you know, the roots are rational as well. Okay. Second case, if P is equal to 1, so then the roots are real and equal. P is equal to 1, delta is equal to 0. So, the roots will be always rational when delta is equal to 0. Real and equal. Okay. Right. I said rational, sorry. So when delta is equal to 0, the roots are real and equal. Fine. Okay. But then at the same time, if P is rational, in the entire problem with the P is rational, then, the roots are rational as well. Okay. If P is rational, there won't be any root in the quadratic equation. Okay. Over here. Third one, x minus a, x minus b is equal to ab. So x square minus a plus b into x plus ab is equal to ab. So this is gone. So x square minus a plus b into x equal to 0. A equal to 1, b equal to minus of a plus b, and c equal to 0. So delta b square minus 4ac. So minus a plus b the whole square. Now 4ac will be 0 because c is 0. Okay. So this is a plus b the whole square. Now this is square. This is square. So it is greater than or equal to 0. So two cases. It is greater than 0 if, a and b together they are not equal to 0 at the same point of time. Okay. So it is greater than 0 only if a is 0, b is non-zero, or a is non-zero, b is 0, or a and b both are non-zero. So square of anything of such category will be greater than 0. So in this case, the roots are real and unequal. But then if a and b both are 0, delta will be equal to 0. So the roots are real and equal. Okay. So let's go to question number 4. Question number 4, sub question 1. Prove that the roots of the equation are always real. So the quadratic equation is x square minus 2ax plus a square minus b square minus c square equal to 0. Okay. A is equal to 1, b equal to minus 2a, c is equal to a square minus b square minus c square. Okay. So delta b square minus 4ac. So b square, b is minus 2, the whole square minus 4 a and c. So 4a square minus 4a square plus b square plus c square. So this is gone. So this is greater than or equal to 0. They are asking us to prove whether it is real. So greater than 0 or equal to 0, they're always real, right? It can never be lesser than 0, this particular value, because of the squares. So it is only greater than 0. Okay, we are not bothered about being equal or not. So let's not get into those cases. So since it is greater than or equal to 0, therefore the roots are always real. Okay, right? And if you want to understand what are the cases, if b is non-zero, c is 0, or vice versa, or both are non-zero, then it will be only greater than 0, roots are real and unequal. And if b and c together are 0 at the same point of time, delta will be equal to 0, so the roots are real and equal. Okay. 4 sub question 2. 4 sub question 2. Show that the roots are always real. Okay. So x minus a, x minus b, ab x square. So x square minus a plus bx plus ab equal to ab x square. X square minus ab x square minus a plus b into x plus ab equal to 0. X square 1 minus ab, a plus b into x plus ab equal to 0. Okay. So a is equal to 1 minus ab, b is equal to minus a plus b. Okay. And c is equal to ab. So delta b square minus 4ac. So minus of a plus b, the whole square, minus 4a. A is 1 minus ab and c is ab. Okay. So this is a square plus 2ab plus b square minus 4ab into 1 is minus 4ab, minus minus is plus 4 a square b square. Okay. So this part, a square minus 2ab plus b square plus 4a square b square. So this is a minus b the whole square plus 4a square b square. Now all squares are there, even plus 4 is positive. So this is greater than or equal to 0. Greater than 0 when a is non-zero and b is 0, or a is 0 and b is non-zero, or both are non-zero. So in that case, a delta will be greater than 0, roots are real and unequal. Okay, but if a and b together they are 0 at the single point of time, delta will be equal to 0. So the roots will be real and equal. That is case 2. Okay, those conclusions you can write. Yeah. Question number 5. Question number 5. x minus a, x minus b, x minus b, x minus c, x minus c, x minus a equal to 0. So x square minus a plus bx plus b square, x square minus b plus cx plus bc. Okay, I'm writing directly because plus c square, sorry. I'm writing directly because if you simplify, you can take something common and you'll get the middle terms, okay? Plus x square minus c plus a into x plus ac. I think one second. This should be ab, this should be bc, and this should be ac, okay? So x square, x square, x square, 3x square minus the negative terms I'll just group, which has coefficient, which are the coefficients of x. So I'll just put x over here, okay? So if we add this, minus is gone outside the box bracket. So if we add this, it will be 2a plus 2b plus 2c into x. Okay. Because within the box bracket, it will be addition of all these three terms. Plus ab plus bc plus ac equal to 0. Okay. So this is a. This along with the negative sign is b. And this is c. Okay. I'll calculate delta. B square minus 4ac. Okay. So minus of 2a plus 2b plus 2c the whole square minus 4ac. A is 3 and C is this. AB plus BC plus AC equal to 0. Take 2 common over here. So minus 2 will be outside like this. So minus 2 square is 4. A plus B plus C the whole square. Minus 12. Okay. By mistake, I wrote equal to 0. That should not be equal to 0. Okay. Yeah. Minus 12. AB minus 12. BC minus 12. AC. Now A plus B plus C the whole square is A square plus B square plus C square plus 2AB plus 2BC plus 2CA minus 12AB minus 12BC minus 12AC. Okay. So this is going to be 4A square plus 4B square plus 4C square. 4 into 2, 8. 8AB minus 12AB will be minus 8. 8 minus 12 will be minus 4AB. Okay. Minus 4AB. Okay. Then 4 to the 8. 8BC minus 12BC will be minus 4BC. Okay. And the last one will be 8CA minus 12CA will be minus 4CA or AC, right? Okay. So what you can do is you can take 4 common over here. 4a square plus b square plus c square minus ab minus bc minus ca. Okay. Now This is equivalent to, okay, I'll do one thing. A square, I'll group it with AB. A square minus AB, B square minus BC, C square minus CA. 4 A 1 minus B, B 1 minus C, C 1 minus A. Okay. Just a second. Let me just have a good look once again. Yeah. So basically, one second. After this step, I'm just changing my strategy because the thing which I was trying was leading to nowhere. So I'll just take 2 common over here. Okay. I'll take 2 common. Okay. So 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Okay. So 2a square. So I'll just write a square minus 2ab plus 2b square. So this is b square plus, out of 2a square there is one more a square left. So a square minus 2bc plus c square. Okay. Now a square are completed. A square plus a square is 2a square. Now only b square and c square one are left. So I'll just write b square minus 2. I think it should be AC over here. Sorry. Minus 2bc plus c square. Okay. Right. So this terms I'm keeping it same for all three. Okay. And then a square. 2a square is written as a square in one term, a square in the other term, in the other group. Okay. That's how I do it. So now this is a minus b the whole square, then a minus c the whole square, b minus c the whole square. Now these are all squares. Squares cannot be negative. Okay. So this is always greater than or equal to 0. Delta. There are two cases when delta is greater than 0. So A, B, and C are unequal. They're not same. Okay. And if A, B, and C are equal, all three are equal, then this values will be 0. So in that case, delta will be only equal to 0. Okay. So two cases, greater than 0 will occur. Delta will be greater than 0 when A, B, and C are unequal. Okay. Any two are equal is fine. All three should not be equal. And if all three are equal, then the roots are, then delta is equal to 0. So the roots are real and equal. Okay. Question number 6. Question number 6 is find m so that the roots may be equal. This is relatively a simple problem. So 4 plus m into x square plus m plus 1 into m plus 1 into x plus 1 equal to 0. So a is equal to 4 plus m, b is equal to m plus 1, c is equal to 1. Delta is equal to 0. Now this is the condition given in the problem because the roots are equal. So b square minus 4ac equal to 0. So b square is equal to 4ac. So m plus 1 the whole square is equal to 4ac. So just solve this, you'll get the values of m. Okay, you'll get a quadratic or something like that. Okay, question number 7. Okay, so the quadratic equation is x square 2 into 3a plus 5 x plus 2 into 9a square plus 25 equal to 0. This is the quadratic equation. So a is 1, b is this 2 into 3a plus 5, and this is c. Okay, a is 1, just remember. So delta we'll find out. We are just proving that the roots are complex. So 2, 3a plus 5 the whole square minus 4 into a into c. 9a square plus 25. 9a square, 30a plus 25 minus 8, 9a square plus 25. Okay, 36a square, 120a plus 100 minus 72a square minus 200. Okay, 36 minus 72 is minus 36a square. Okay, plus 120a minus 100. Okay, so I think something is common over here. 4 is common. Let's take minus 4 common. So this will be 9a square minus 30a plus 25. Okay, now 9 into 25 is 225. 15 into 15, because 15 15 will give you 30. So minus 4, 9a square minus 15a minus 15a plus 225 equal to 0. Minus 4, take 3a common, 3a minus 5 minus 5 common. One second, I think minus 15 common, sorry. Okay, and this is 3a minus 5. Okay, so minus 4 into uh, just a second. This is not 225, sorry. This is 25, okay? The last term is 25. The multiplication is 225. Sorry. Okay, so 5 is common over here. Yeah, so this will be 3a minus 5 into 3a minus 5. So minus 4 into 3a minus 5 the whole square. Now this is square. Square is positive. Positive into any negative number is negative. Okay. The only place where this is going to be 0 is when a is equal to 3 by 5. Oh, sorry, 5 by 3. Okay, equate this to 0, you'll get a critical point. So at a equal to 5 by 3, if a is equal to 5 by 3, delta will be equal to 0. So the roots are real and equal over there. But then if a is not equal to 5 by 3, then square into this negative number will be negative, less than 0. So it will be complex. Okay, that was question number 7. Let's go to question number 8. Okay, a square plus c square x square plus 2ab plus cdx plus b square plus d square equal to 0. This is a, this is b, and this is c. So delta b square minus 4ac. Okay, so this will be 4 a square b square plus 4 c square d square, 4 to the 8 a b c d minus 4, I'm just multiplying this now. 4a square b square minus 4 a square d square minus 4 b square c square minus 4 c square d square. Okay, so some terms are getting cancelled. 4c square d square, 4c square d square, 4a square b square, 4a square b square got cancelled. So we are left with this and this a b c d. I'll just take minus 4 common and I'll rearrange the terms. Minus 4 common. So it is a square d square minus 2 ABCD. I'll just write ADBC. One and the same thing. ADBC plus B square C square. Now this is what? AD minus BC the whole square. Okay. Minus 4 AD minus BC the whole square. This is delta. Now this square into this negative will be less than 0. So case 1, if value of A into D value of A into D and value of A and B into C is equal. If we multiply A into D and if we multiply C into D, if they are equal, then only delta will be equal to 0. Otherwise, it is complex. Okay, so that is your conclusion. Fine. Let's go to question number 9. Okay. Now in the problem, in question number 8, they are saying it cannot be real. So we have proved it is not real with less than 0. And if A, B, C, D are equal, if A, B, C, D are equal, then obviously AD equal to BC. AD will be equal to BC. Okay. In that case, AD minus BC will be 0. Right? So there it will be real because AD minus BC is 0 over there. Question number 9. ABC are rational numbers. Show that the equation roots of the equation are rational. So ax square plus bx plus c equal to 0. A is a, b is b, c is c. Delta is b square minus 4ac. Okay. Now see, a plus b plus c equal to 0. So b is equal to minus of a plus c. Take a and c on the other side and take minus sign common. So b square will be a plus c the whole square. Negative sign goes a square plus c square plus 2ac. Now this value we are going to put it over here. So delta is equal to a square plus c square plus 2ac minus 4ac. So a square plus c square minus 2ac. A minus c the whole square. A minus c the whole square. Okay. Now this is greater than 0. Square is always positive. But in if a and c are equal, a and c are equal. Okay. So in that case, it will be real and equal. But then if a and c are not equal, then delta will be greater than 0 only. Okay, so I'll just put equal to 0 also over here because it can be greater than also and equal to also. In both the cases, they are real, but then in one case, for greater than 0, it is unequal. Equal to 0, it will be equal. Okay, delta equal to 0, the roots will be equal uh, because delta is equal to 0 and delta will be equal to 0 only if a and c are equal. Okay, now they have given a, b, c, d are rational. Okay, so if a is not equal to c, A and A, B, C are rational. So if A and C are rational, A is not equal to C. So rational minus rational will be a rational number. Uska square is also a rational number. Okay. So there won't be any root in this. So the roots are rational as well. Right. Question number 10. x square plus px minus 1 equal to 0. A is equal to 1, b is so the roots are real and distinct, real and unequal. So there is no question of equal to 0. Unequal roots, real and unequal. So b square minus 4ac is greater than 0. B square, p square minus 4ac greater than 0. So p square plus 4 is greater than 0. Okay. Acha, we are not supposed to write greater than 0 right at the beginning. We are supposed to prove it is greater than 0. Okay. So delta greater than 0 is what we are supposed to prove. I thought it is given greater than 0. Okay. So this is delta. Now this value is greater than 0. Okay. It will be always greater than 0. See if p is 0. If p is 0, then also 0 square plus 4 is greater than 0. And p is non-zero. Non-zero square is positive plus 4 will give you positive number only. So it will be always greater than 0. So there is no question of equal to 0 in this problem. So it is only greater than 0. Okay. Yeah, that was question number 10. Let's go to question number 11. Let's go to question number 11. So x square minus 2m plus 1 upon m into x plus 3 equal to 0. So a is 1, b is this entire thing, and this is c. A is 1 over here. Okay. Show that the roots are real for all real values of m. So now see delta b square minus 4ac. So b square 4 m plus 1 the whole square, because b is this entire thing, minus 4ac. A is 1. Okay. So take 4 common over here. M plus 1 upon m plus 1 upon m the whole square minus 3. So delta is equal to 4 m square plus 1 upon m square minus 2 plus 2. Sorry. M plus 1 upon m the whole square. So plus 2 will come. Plus 2 into m into 1 upon m. M gets cancelled. So plus 2 minus 3. Okay. Plus 2 minus 3. Okay. So delta is equal to 4 m square plus 1 upon m square minus 1. Okay. Now this is not a perfect square. What I will do is m square plus 1 upon m square. I'll write minus 2 because this is m minus 1 upon m the whole square. So if I'm writing minus 2, so here I'll have to add 2 also. Okay. Right. So I'm subtracting minus 2, I'm adding plus 2. Minus 1 remains the same. Minus 1 remains the same. Fine. So 4, this will be 4 m minus 1 upon m the whole square plus 1. Okay. This is going to be plus 1. So this is square of any negative or positive number will be positive only. Okay. Now m is non-zero. It's given in the problem. M cannot be 0. So m can take up any real value. Any real value square will be positive only. M is any non-zero real value. So this is greater than 0 only, because square plus 1, positive plus 1 will be positive, and this positive into 4 will be positive itself. Okay. Right. So it is always greater than 0. It can never be equal to 0. Right. Okay. So that is the answer. Now, in this problem itself, some students might have a doubt why it is not equal to 0. Okay. See, because this square will never give you minus 1. So in that case, -1 plus 1 will never be 0. So square will always be positive, okay? So that's why, I'm just avoiding that discussion of why it is not equal to 0, because it won't be equal to 0. Okay, let's go to question number 12. Question number 12. If the roots are real and distinct, okay, so the quadratic equation ax square plus 2cx plus b, the roots are real and distinct. So a is a, this is b, and this is c. Okay, so roots are real and distinct. So delta is greater than 0 over here. So the roots are real and distinct is given. We are not assuming. So b square minus 4ac is greater than 0. B square. So 4c square minus 4ab greater than 0. Take 4 common. C square minus ab greater than 0. C square minus ab is greater than 0. See, because 0 divided by 4 is 0 only, and 4 is a positive number, no sign change. Okay, this is one condition we got from the first quadratic equation. Now we need to prove that the second equation will have complex roots. The second equation is x square minus 2a plus b into x plus a square plus b square plus. So this is the second quadratic equation. So b square minus 4ac, we are finding out the delta. B square. So 4 a plus b the whole square. So 4a square plus 4. Directly I'm writing. I'm finding out the value of b square. 4b square plus 2ab into 2. 4ab. Minus sign goes because of the square. Minus 4 AC. A is 1. So minus 4a square minus 4b square minus 8c square. Okay. So 4a square gone. 4b square gone. So 4ab minus 8c square. Okay. 1 second. Yeah. So let me just have a look at this once again. Okay. I think I took too many shortcuts. Just wait. So basically, this is going to be 8, because I took a lot of shortcuts. Yeah. So 2ab into square of this is 4. So 4 into 2 is 8. Okay. So this is going to be 8. So 8 ab minus c square. Now see, c square minus ab is greater than 0. So ab minus c square will be lesser than 0. So this value is negative. This value is positive. So positive into negative is negative. Hence, this is lesser than 0. Okay. Roots are complex. Question number 13. Question number 13. A into b minus c, x square plus b into c minus a, x plus c into a minus b equal to 0. Okay. So the roots are equal over here. It's given. So delta equal to 0. It's given. So b square minus 4ac equal to 0. B square. B into c minus a the whole square minus 4 into a b minus c, c a minus b equal to 0. B c square plus a square minus 2ac minus 4ac b minus c into a minus b equal to 0. So this is bc square plus ba square minus 2abc. Okay. Minus 4ac. Multiply this to round brackets. So that is ab minus b square minus ac plus bc equal to 0. Okay, so bc square plus ab square, bc square plus ab square, bc square plus ba square, ba square. Okay, then minus 2 abc minus 4 a square bc plus 4 acb square plus 4 plus 4 a square c square minus 4 abc square. Okay, equal to 0. So this is one big complicated term. Okay, so I just missed out on this square, so I'll just put a square over here. Okay, because it has to be b square also, na? So this is the bracket which I missed. So I'll just put all the squares over here. Okay, so this is going to be b square c square plus b square a square plus 4 a square b a square c square. Okay, now look at these two terms, this term and this term. So it is going to be 2 ac b square minus 4 a square bc minus 4 abc square equal to 0. Now guys, this is a very complicated term. Okay, so commit to memory this particular step. bc plus ab, this is ac, so right, minus 2 ac, the whole square equal to 0. Because if you expand this, you'll certainly get this. Now this part absolutely is very tricky, okay, to teach and for you to understand. So this you commit to memory, okay. So this is equal to 0, taking square root on both the sides. bc plus ab minus 2ab equal to 0, minus 2ac equal to 0. So bc plus ab is equal to 2ac. Take ac on the other side, split. Okay, cc gone, a gone, b upon a plus b upon c equal to 1. So take b common, 1 upon a plus 1 upon c equal to 2. Therefore, 1 upon a plus 1 upon c is equal to 2 by b, equal to 2 by b. Fine. Question number 14. See, they have given the quadratic expression. It is not equal to 0. So that expression is a perfect square. So we have one property. If the quadratic expression is a perfect square, then the roots are real and equal. Okay. Again, I'm telling you, 14th sum, it's not a quadratic equation, it's a quadratic expression, it's a perfect square. So if a quadratic equation is a perfect square, so delta equal to 0. Remember this. So b square minus 4ac equal to 0, b square is equal to 4ac. Now b over there is 2 into k plus 2, the whole square. Okay, put this brackets and all, otherwise like the previous problem, we might go wrong somewhere. Okay, so 4 minus k and This is 8k plus 1. So you solve this, you'll get the answer. Fine. You'll get the values of k. 15 sum. The roots are real and distinct, so delta is greater than 0. It's a quadratic equation this time, not an expression. So b square minus 4ac is greater than 0. Okay. So b square minus 8d whole square minus 4ac. A is 1. So m into m minus 6 is greater than 0. 64 minus 4m square plus 24m is greater than 0. Minus 4m square plus 24m plus 64 is greater than 0. Take minus 4 common. M square minus 6m plus 16 is greater than 0. Now when you divide with minus 4, there will be sign change, inequalities, division with a negative number. Okay, and this will be negative, sorry. Okay, m square minus 6m minus 16 less than 0. Greater than became less than 0. Okay, because we are dividing with a negative number. So m minus 8, m plus 2 less than 0. Now this you know to solve by number line method, plus minus plus, that particular method is, you can solve this. Okay, so that is the end of this particular exercise.